Hello friends, as we are seeing over here the plane stress and plane strain in unit number 4, that is two-dimensional vector analysis. Okay, so see, we will first see the basic concept of plane stress and plane strain. Now we will know why we need the plane stress and plane stress study, because we are using this plane stress and plane stress in our finite element formulation, finite element analysis. Okay, for the plane stress we can define it as the state of stress in which the normal stress and the shear stress directed perpendicular to the plane are assumed to be zero. For an instance, the plane xy shown is subjected to the traction, as we can see over here. This is traction, okay, and the force per unit area, that is stress, in the plane which are under the plane stress, and that is the normal stress sigma z, and the shear stress, that is tau xz and tau yz, which are also acting on that. So these two force stresses, that is shear stresses tau xz and tau yz, are assumed to be zero. Then generally this member are considered as thin, and the stress in plane xy can be considered to be under plane stress. Okay, so similarly we can see the what is plane strain. It is also defined as a state of strain in which the strain is normal to xy plane, and that is epsilon z, and the shear strain, that is uh, in xz and yz, gamma xz and gamma yz are assumed to be zero, and the assumptions of the plane strain are realistic and for the long bodies, say z in the z direction. So constant cross sectional area subjected to the load is always under the plane strain. Okay, so we can see over here the diagram. In this we can see the traction is acting over here, and in this b diagram a, the plane stress, that is the plate with hole, and second is plate with fillet, so that the plane stress can act over here and for this over here. So in this example we can see the plane stress. uh, this is suppose this is the dam, and this is the wall of the dam. The pressure due to the water which is acting on the dam wall, so it is considered as a plane strain, plane stress on the wall. Here also a cylinder or a pipe which is subject to the vertical load, so that this plane is considered as a shear plane stress plane. Okay, so how can we define the two-dimensional state of stress and strains? So basically we can consider this two-dimensional stress, that is sigma x, that is in x direction and y direction, and what we can say shear stress in xy plane. So we can see here in this diagram that the sigma x in rightward and leftward direction is acting, and sigma y upward and downward direction is acting. Similarly here tau yx and tau xy, which are in opposite direction and equal magnitude, and tau xy and tau tau xy both are in opposite direction. Okay, so this is two dimensional one, and we can see this principal stresses, that is uh, we can see the maximum and minimum normal stress in the two dimensional plane can be obtained by the following equation. Sigma 1 is equal to sigma x. So sigma 1 and sigma 2 are the principal stresses which can be obtained with this formula, that is sigma 1 sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 bracket square plus tau xy square, and it is always at the maximum stress, and the minimum stress, that is sigma min, will be given by sigma x plus sigma y divided by 2 minus under root of sigma x minus sigma y divided by 2 bracket square plus tau xy square. So now we can find the angle, that is principal angle we can say, which is the normal whose direction is perpendicular to the plane which is maximum or minimal principal stress, which is acting and defined by the tan 2 theta p is equal to 2 tau xy divided by sigma x minus sigma y. So we can see in this figure that sigma 2 and sigma 1 are the principal stresses which are acting, and the angle between this face, that is sigma 1 with horizontal, it is called as that principal angle. Now we can see the figure, that is 6, the infinitesimal elements used for representing the general two-dimensional state of strain at some point in the structure. So what we will see, the incremental amount is du by del u by del x by into dx along with a line AB, and du by del y into dy along AC. What we can see over here, A, B, C, these are the three vertices of this rectangle, and the original position is shown in dotted line, and the length is considered as dx, and height, that is mm, height, what we can say, length in y direction is dy, which is considered. So now the deflection in x direction is u, and deflection in y direction is v. So with this deflection, and what this angle is also, deflection angle is also given because of the strain which is coming in this diagram, or what we can say in this block, so that it is getting distorted from its original position, and that value will be equal to, as we have seen recently in by du by del u by del y into dy, the value in between this, the angle between this will get del u by del y, and the angle between these two will be del u by del x. So now the value will be equal to del u by del x into dx, and this one value will be equal to u plus del u by del x into dx. So we can elaborate this strains, that is in epsilon x in x direction del u by del x, epsilon y del v by del y, and stress shear strain in xy plane, that is del u by del y plus del v by del x. So now you can see, or you can show this in vector form. that is epsilon is equal to epsilon x epsilon y, and shear stress that is gamma xy. So further we can see over here this the values of stress which are considered as a 0, but epsilon z is not always equal to 0. So we know that sigma is equal to uh, d epsilon. So here d is equal to e upon 1 minus gamma square nu square 1 nu 0 nu 1 0 0 0 1 minus nu 2. So here we can see similar for the strains. This one is the d element for strains. So now you can elaborate this with the stresses and strains. The matrices remains the same for the plane stress case. The basic partial differential equation for the equation for plane stress as it is derived like this: del u del 2 u by del x square plus del 2 u by del y square is equal to 1 plus nu divided by 2 del 2 u by del y square minus del 2 u by del x into del y, and del 2 v by del x square plus del 2 v by del y is equal to 1 plus nu divided by 2 del 2 v by del x square minus del 2 u by del x into del y. Thank you friends. Thank you very much.